Okay, it's recording now. Awesome. Okay, so we want to be able to find determinants of 2x2s and 3x3s today. We want to decide if matrices are invertible, and we want to be able to find inverse matrices. So here we go. The first thing we're going to talk about today is the determinant. So the determinant of a matrix helps us to determine if it's going to have an inverse or not. Okay, so it helps us determine if a matrix has an inverse. So first of all, we have some notation. So if I have a matrix A, and we'll say that this matrix is just, A, B, C, D, any numbers. This is kind of a generic 2x2 matrix. The determinant of A is like the capital A with absolute value symbols. And what it would be equal to is the matrix itself in absolute value symbols. Just those bars like that. So that's some notation. That means determinant. Okay. And so for a 2x2, the determinant of matrix A is equal to A times D minus B times C. So basically you multiply on the diagonals and subtract. Multiply on the diagonals and subtract. And you're going to get one single number. You're not going to get a matrix back out of this. You just get a constant. So for example, if I wanted to, if my matrix was, let's say it's the matrix 1, 2, 3, 4. The determinant of that matrix would be 1 times 4 minus 2 times 3. So we just multiply on the diagonals and subtract. So that would be 4 minus 6, which is -2. So the determinant of that matrix is -2. Okay. So I'll give you guys one to try. Here's matrix B. Matrix B is -3, 4, -1, 7. Go ahead and find the determinant of B using that same process. And once you've got it, type done in the chat. All right, looks like most of us have it. If you got -17, you are correct. So just careful with your negatives and everything, and then we should be good. Okay, so that's finding the determinant of a 2x2. Before we talk about determinants of 3x3s, we're going to talk about inverses. And first of all, also, I didn't say this before, but only square matrices have determinants. So if you have a matrix that is not a square matrix, then you're never going to need to find a determinant of it because it does not have one. So this only works for square matrices. And then so likewise, inverse or only matrices that are square matrices will have an inverse. So we're going to talk about inverse of a 2 by 2. So for inverses in general, only square matrices have determinants and inverses. Okay, so just as kind of a side note, there we go. So first of all, if we're going to find an inverse, we have to figure out if it's going to be invertible or not. So here's the rule. A matrix is invertible if, well, can't spell. If is not F-I, it's I-F. All right, a matrix is invertible if the determinant, and I'm just going to abbreviate it with DET, is not equal to 0. So the matrix must have a determinant that is not 0 in order to have an inverse. And the word that we use for being invertible in math is not singular. So the vocab word for this is non-singular. So if it has an inverse, that means it's non-singular. And then we'd say also a matrix is not invertible if the determinant is equal to 0. So not invertible, the vocab math word for that is singular. So the way I like to think of remembering singular versus non-singular is if a matrix is invertible, that means it has an inverse, it has a partner, right? It's not single. And if a matrix is not invertible, it's all by itself, it's single. So if it's invertible, that means it's non-singular because it's not alone. If it's not invertible, it's singular because it's alone. Okay, and so the rule we have to remember that you'll see why it's immediately obvious once we go to talk about inverses and how we calculate them, why the determinant can't be 0. So let's go do that. I'm going to grab another piece of paper. Okay. So finding the inverse of a 2 by 2. So let's say our matrix A is A, B, C, D. So there's our 2 by 2 generic matrix. A inverse equals 1 over the determinant of A times, we switch the ones that are on the main diagonal, so this becomes D and this becomes A. And then we make we change the sign on the other diagonal, so that becomes negative B and negative C. And remember, we've done multiplying a matrix by a constant, so you would just take 1 over the determinant and multiply that by each of the terms in your matrix. Okay, so let's do an example of that. We're going to do that with our matrix 1, 2, 3, 4 from above. So if we go back to that example, we remember that the determinant was -2. So that was from our previous example. The determinant was -2. So first of all, is this matrix invertible or not invertible? Is it non-singular or singular? What do we think? Will this have an inverse? Type yes in the chat if you think it has an inverse. Type no in the chat if you think it doesn't. Or you can use the appropriate vocab word. All right, we got it. Yes, it does have an inverse. It is non-singular because the determinant is -2, which is not 0. So now we can go about finding that. A inverse. So the first thing we do is go 1 over the determinant. 1 over -2. And then we multiply this by our new matrix. So the first thing we want to do is switch the ones on the diagonal. So 1 and 4 are going to trade places. And then we make the ones on the other diagonal negative. So -2 and -3. Okay, then we multiply through by this 1/2, or -1/2. So we're just basically taking and dividing all of the terms by 2. So it becomes 4 divided by -2 is -2. -2 divided by -2 is +1. -3 divided by -2 is 3 over 2, or 1.5. And then 1 divided by -2 is -1/2. So this would be our inverse matrix. Okay, so the steps there are just find the determinant, switch the first diagonal, change the sign on the second diagonal. Okay. So those are the basic steps. I'm going to give you guys one to try now. We'll say our matrix is, we'll go with that one that we had from before. Or actually, just kidding. We'll make up a new one. 2, -1, 4, -3. Find the inverse if it exists. If it does not exist, say does not exist. Once you think you have it, type done in the chat. All right, looks like most of us are finishing up here. You're on the right track if you found that the determinant is -2. That was just a happy coincidence that it was the same as the previous one. I guess I use similar enough numbers, but anyway. So for our inverse matrix, if you're checking your answer, here it is. If you're not done yet, keep working on it, and then check your answer. Okay, so we should have gotten 3/2, -1/2, 2, -1 for our inverse. So remember, we just switch the ones on the main diagonal and then change the sign on the opposite diagonal. And then divide through by your determinant. Okay, so on a scale of 1 to 5, 1 being I'm totally lost, 5 being this is super easy so far, how are we feeling about finding inverses of 2x2s? Okay, looks like we're mostly in the 3 to 4 range. We'll do one more. And then we'll talk about 3x3s and how we would do those with a calculator. Call this one matrix B. We'll say it's -5, -2, -1, 0. Find the inverse of matrix B. Once you think you've got it, type done in the chat. You're on the right track if you found the determinant of the matrix is 2. Because remember, we multiply the diagonals and then subtract. And then we switch the main diagonal so that it becomes a 0 in the top corner and a -5 in the bottom corner. And then we make this a -2 and make the -1 into a +1. And our inverse matrix becomes 0, -1, 1/2, -5/2. Okay. So that's finding matrix or inverse matrices of 2x2s in a nutshell. Let's go ahead and do, we'll talk about determinants of 3x3s and how you would calculate it by hand if you wanted to, and then we'll break out the calculators. Determinant of a 3x3. Okay, so let's say we've got this 3x3 matrix, A, B, C, D, E, F, G, H, I. So there's our 3x3. And the determinant of this is going to seem really weird. I'll put down the formula for it, and then I'll kind of explain the theory behind it. So we take A, the top left corner value, times the determinant of the mini matrix E, F, H, I. And then we subtract the middle of the top row times the determinant of the mini matrix D, F, G, I. And then we add the third row C times the determinant of the mini matrix D, E, G, H. So the idea here is when you're going through and making this formula is you take the first row, or the first one that you're multiplying out in front, A, and you kind of cross out the row and the column that A is in, and then that gives you this matrix that you find the determinant of and multiply it by this. Then you do the same thing with B. You cross out the row and the column that B is in, and then what's left is DFGI. And so that becomes this matrix here. And then you do the same thing for C. You cross out the column and the row that C is in, and you're left with this matrix here, DEGH. Okay, so that's the theory behind it. If we were going to calculate one by hand, I'll show you calculating one of them by hand, but then we're going to jump to calculators. So we'll say our matrix is 1, 2, 3, 2, 1, 3, 3, 2, 1. Okay, because they're low numbers and easy to work with. So the determinant of A would be, so our A value is 1 times the determinant of 1, 3, 2, 1. And then minus the B value, so 2, times the determinant of 2, 3, 3, 1. That's kind of, if we went like that, we'd have that left over. And then plus C, which is 3 in this case, times the determinant of 2, 1, 3, 2. And then this becomes something that we've seen before, just a bunch of determinants of 2x2s. So we would go for this determinant 1 times 1 minus 3 times 2. Then minus 2 times the determinant of this, so 2 times 1 minus 3 times 3 plus 3 times the determinant of this, so 2 times 2 minus 3 times 1. And then we go through and simplify. So here we've got 1 times, and that's 1 minus 6, which is negative 5. Minus 2 times, let's see, we have 2 minus 9, which is negative 7. Plus 3 times, we have 4 minus 3 is 1. And we end up with 12. So the determinant of this 3 by 3 matrix is 12. And that's a lot of work to find one determinant. So let's break out the calculators. If you have a TI calculator, I will show it there first. If you don't have a TI calculator, I will show it on Desmos after that. So while you're waiting, if you don't have a TI calculator, open a window of Desmos matrix. If you do have a TI calculator, grab that, and we're going to find determinants here. So we go to second matrix, and we're going to go over to edit, and we're going to make ourselves a 3 by 3. You can make whatever size you want. You could, yeah, other sizes will work, but I'm going to go with a 3 by 3. And I'm just going to type in some numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll have that be our matrix. Okay. Then we'll go, I'll wait a sec actually and make sure everyone's got their matrix typed in. Type yes in the chat if you've got a 3 by 3 matrix in your calculator. All right. Looks like most of us have one. When you've got one, type second quit to get out of that. And then go second matrix and go to the math tab. And it's the first thing that comes up, DET. So hit enter. And then you got to bring up your matrix. So you have to go second matrix and then choose matrix A. And it finds the determinant for you. And the one that I typed in happens to have a determinant of 0. So what would that tell me if my matrix has a determinant of 0? Right, can't inverse it. It is singular. It's all by itself. Yep, okay. So if my determinant is 0, my matrix is singular. So to go and do inverses now, I'm going to go and find or change my matrix to make it something that's invertible. So second matrix, we're going to edit that. I'm going to change a couple of the numbers here. Okay, so I made that a 5, an 8, and a negative 2 instead on the top row. I think that should be enough. I'll double check though. We're going to go find the determinant of it again. And lo and behold, we get a better determinant here, 39. Okay. So now if I want to find the inverse, it's actually a little bit easier. You don't have to go into the matrix operations and everything. All you have to do is call up your matrix. So get matrix A out there. And then you just hit the x to the negative 1 button, because that means inverse, and hit enter. And it will give you the inverse matrix. Okay, there we go. Yeah, so you can scroll back and forth and see your inverse matrix. Okay, and you can do that with 2x2s in the calculator too, but with 2x2s, I find that rather than typing it into the calculator, it's actually quicker to calculate it by hand. Okay, let's go do Desmos real quick. It's very similar. It's pretty quick. Desmos matrix. So if you are following along on the Desmos, we're going to make a new matrix. And I'm going to make it a 3x3. And we'll go 5, 8, -9, 3, 6, 1, 2, 4, 8. I don't know. I just typed random numbers for the sake of showing this. Okay, so there's our matrix full of random numbers. Finding the determinant, you just click determinant and then click A. And it tells us the determinant of this particular one is 44. And then to find an inverse, you just go click A for the matrix A, and then to the -1 to find the inverse. And it tells you what your inverse matrix is right there. You can also convert it to fractions in Desmos matrix, which is kind of nice. So if you wanted to see the fraction versions of things, you can make it decimals and fractions just by clicking that. So that's handy. Any questions so far with using the calculators to find inverses and determinants? Anybody stuck in a particular place with their calculator? Okay. Yeah, I can do it again on Desmos. So here we go. If I wanted to do this with, we'll make matrix B. We're going to do 3 rows, 3 columns. And I'm going to type in random numbers like 2, -9, 7, -4, 3, 2, 5, -6, 0. And I'm going to hit enter. So that saves my matrix. To find the determinant, I just select DET and my matrix. And it tells me my determinant is -3. If I want, and then I just hit enter to get a new line. And if I want to find the inverse, I just click matrix B. And then that -1 power button is the inverse button. And so it gives me my inverse matrix, and you can also make it into fractions if you would like, or decimals by toggling there. Cool. Okay. So I'm going to post the assignment and talk about that real quick. One moment. We are in IXL today. Okay, so today our assignment is in IXL. There are 3 sections, but here's the instructions. So the first one is L10, and it's finding the determinant of a matrix. If it's a 2x2, I would like you to do it by hand to get the practice. You can check it on the calculator if you want. If it's a 3x3, feel free to use a calculator. Then we have inverse of a 2x2. I would like you to do that one by hand. But inverse of a 3x3, feel free to use a calculator. Any questions on what we're supposed to be doing for our assignment for today? Okay, make sure that you log in with Clever so that it saves your progress. I had a few people first period who were kind of sad because it did not save their progress because they didn't log in. So make sure you log in. And you have time now to work. This class is over at 1:45. So let's say at, we'll go at 1:35, come back. And we'll talk real quick and then we'll be done for the day. So at 135, come back.